functions. I want you to pay attention though. Some of these could potentially give you, and I don't know if they give you all of them. On your quiz, I think I give you all 3 sides. So I don't just give you the 2 sides you need. So just so you know, that's a little bit different on your quiz. Or if I don't give you all 3 sides, you may have to solve for it. And I haven't even looked to see if you have to solve for this one. So don't just assume that you're going to use the sides you have, is what I'm saying. You could have all 3 of them, and so then you have to pick. Or you could have 2, and you actually have to use Pythagorean Theorem to solve for the 3rd side. So just make sure you're paying attention. You might not necessarily use these 2, which I don't think you actually do on this one. So make sure you are refreshed on Pythagorean Theorem as well. All right, so secant, that is the reciprocal of which one? Cosine, which is adjacent over hypotenuse. So we're going to need hypotenuse over adjacent, okay? So hypotenuse over adjacent. So this is one that it's going to be where you need it. This is what I wanted to make sure we had. So we don't have the side we need. We have to use Pythagorean Theorem to solve for it. Make sure that you're also aware that your C of your Pythagorean Theorem is always your hypotenuse, the side opposite your right angle, okay? So in this case, I'm going to say a squared, that's 11 squared, plus b squared, which I don't know, equals c squared, which is my 16 squared. Then I'm going to solve. Is that right? All right, so subtract 121 from both sides. All right, 135 doesn't have a perfect root. For these, I want the exact value. I mean, I don't want it rounded. Obviously, we're leaving them in fraction form. So you do need to do your factor tree here, which means you're going to have to, you know, pretty much. All right, so when you do this particular factor tree, you see the 3's pair up. The 5 does not have a pair. The 3 does not have a pair. If it has a pair, it goes out. If it doesn't have a pair, it must stay in. There we go, 3 square root of 15. So I now know that this side is 3 square root of 15. All right. All right, so now we know this. We know that secant then is going to be hypotenuse over adjacent, because it's the reciprocal, right? So it's hypotenuse over adjacent. We do not want to leave this like this because it's the square roots on the bottom. So we're going to rationalize it by doing this process here. So we have 16 square root of 15 over, remember square root of 15 times square root of 15 is just 15. So 3 times 15 is 45. That doesn't reduce. So you are actually done. If it did reduce, you would go ahead and reduce the 16 and the 45. But since there's nothing that goes into both of those, you just leave it alone. So the next one, they basically have given you the same thing without drawing a triangle, okay? So they have given us one piece, cotangent. Cotangent is what? Cotangent is what over what? Okay, so think of your SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So cosecant is going to be reciprocal of that. Secant is going to be reciprocal of that one. And cotangent is going to be reciprocal of that one. So cotangent, they've given us cotangent. They've given us adjacent over opposite is what they've given us here. Okay? They want us to find cosecant. Now cosecant is across from my sine. So I need hypotenuse over opposite here is what I need. Correct? So yeah, if you don't know this is a Pythagorean triple, 3, 4, and 5 always go together, right? That's a perfect Pythagorean triple. If you don't know that, your opposite and adjacent are always your legs. They're A and B. So you can say 3 squared plus 4 squared. Your hypotenuse is always your C, okay? And so you're going to say 9 plus 16 equals C squared. That means 25 equals C squared. That means C equals 5. So I know that my hypotenuse is 5. So my final answer here is going to be hypotenuse over my opposite, which they gave me in the problem. So for this one, I am missing the angle. My instructions say, find the angle. So I know that I'm going to use an inverse trig function, all right? What I do still need to figure out is what these sides are in relation to this angle. The hypotenuse, well, he's easy because he's opposite that right angle. So what is the 4? Is the 4 adjacent or opposite? Adjacent. It is part of that angle, right? It's part of that angle, so this is adjacent. So which of my 3 basic functions deal with adjacent and hypotenuse? Yeah, cosine. So I'm going to use the inverse function of cosine. I'm going to say my cosine, that little inverse guy, should be my adjacent over my hypotenuse. And this is actually one of your common angles you're supposed to know. So we're looking for the inverse of a 1/2. That is a 60-degree angle. But if you don't know that, you can put that into your calculator. Cosine inverse of 0.5, and you will get 60 degrees there. If for some reason, now it is possible, 60 degrees, this is a perfect one. It's one of your unit circle ones. However, not all of them will be perfect ones. You will need to round to the nearest tenth, which is what this is telling you here. So make sure you understand your rounding. Look at your 10th place. Look 1 over, 5 goes up, 4 below stays the same. So just make sure you do your rounding right. Those are really annoying points to miss out on if you round incorrectly. All right. Our regular sine, cosine, tangent here. So on the next group, you're finding a side. Anytime you're finding part of your ratio, you're going to use your regular trig function. It is still in relation to the angle that it gave you here. So it gave us this B, 68. All right. That means X is what? Opposite, adjacent, hypotenuse. It's opposite. 7 is adjacent. Which of your 3 basic trig functions deals with opposite and adjacent? Tangent. So this means the tangent of 68 degrees should equal my opposite side over my adjacent side. Because what I'm solving for is on top, I'm going to multiply both sides by that 7. So 7 times the tangent of 68 degrees should equal my x. You'll notice these instructions also say round to the nearest tenth. And so this one is going to be approximately 17.3. Use all the things we've just done to solve the triangle, meaning all 3 angles have to be labeled, right? And all 3 sides have to be labeled. I will say on your quiz, I would actually prefer you list them out because that's easier for me to grade than to just write them around the little triangle, especially depending on the type of triangle. Like sometimes if you write that 18, I don't know how tiny you write, but it's hard to fit that 18 in there, right? So I would rather you on your quiz write angle A, angle B, angle C, and then side AB, side BC, side CA. And that way 2 things happen here. 1, you can like mentally check, I did all 6 of them. And others, I can actually easily find your answer. And so finding the angles, if they give you an angle, you automatically want to know one is 90. You know the other one they just gave you. Those 2 should add up to 90. So subtract the one that's not 90 from 90 and you get the third guy. If they do not give you an angle, you're going to have to use an inverse trig function to find one of them. And then you can subtract that guy from 90 and find the other, right? You are still using SOHCAHTOA to find all these different pieces, all right? I will say this too. If you have to round a piece, like say you have to round one of your sides or you have to round one of your angles, make sure you write that down so I can see in the process where you rounded. You can also use Pythagorean Theorem if you have 2 of the sides and not the third side. Okay, you can either use an inverse trig function to find an angle, or you can subtract. You can use a trig function to find a side, or you can use Pythagorean Theorem if you have 2 of them. Okay, so you can use more than one type of process to solve something like this, as long as you have all 3 of the angles and all 3 of the sides. And you're just using the 2 that we just did pretty much to solve this. So the section 13 through 16 and the section 9 through 12, you are going to use those processes to solve a triangle. And then you can use, like I said, Pythagorean Theorem or subtraction. All right? Questions on solving a triangle? It's basically just combining those into one big triangle. All right, a man flies a kite with a 105-foot string. The angle of elevation of the string is 45 degrees. How high off the ground is the kite? Now, because they didn't tell you the height of the man, we're going to assume from ground level the angle of elevation, okay? So if they said he was 5 feet tall or whatever, then you would have to adjust for his height. Because they did not, we're going to assume from ground up is that angle of elevation. Make sense? All right. 105-foot string. So let's interpret this word problem. When I am flying a kite, right, you're going to get to see my beautiful art skills in practice here. When I am flying a kite, right, and I have a string, which piece of my right triangle is that string? Yeah, the hypotenuse, right? And I'm actually going to be a little bit neater so that we can have a... So the string is the hypotenuse, okay? So I have this string here, which means... how high off the ground then? That's my vertical, right? Makes sense? And then I really actually don't even care. Oh, okay, I drew him too long, but that's okay. I really don't even care how far across it is in this particular problem. All right? So the string then is going to be my 105 feet, correct? How high off the ground? Well, that is going to be my vertical rise there, okay? Angle of elevation of the string. Well, my assumption is that that's going to be right here. Angle of elevation, all right? And that's going to be 45 degrees. And so when I have something like this, I am going to sketch an image of what's going on, so that I can see what's happening, okay? Because at this point, I have a really easy problem to solve. I've actually already solved it in the quiz, have I not? I'm just solving for a side, which means I'm going to use a trig function that deals with whatever sides I have based on that angle. And so what sides do I have? Well, I have hypotenuse. That's my string, right? And I have opposite. That's this guy here. So which trig function am I going to use here? Sine. And so I should have then the sine of a 45-degree angle equals my opposite over my hypotenuse, all right? And so I have the sine of a 45-degree angle should equal opposite over hypotenuse. So to solve this, I'm going to multiply both sides by that 105. So 105 times the sine of 45 degrees should equal my vertical distance. And it says round to the nearest tenth, so 74.2, and it is feet, because that's how many feet, that's the units that it used for the string. 5 feet, 10 inches tall. Derek looks at a 10-foot basketball goal. An angle of elevation is 29 degrees. Sam looks at the goal, angle of elevation 43 degrees. If he is directly in front of him, how far apart are they? So what you really need to do is you need to take this 10-foot and convert it to inches, which is what? Yes, what a trick question. 120 inches. And then take their height as well. So 5 feet is how many inches? 60, and they're 5'10", so they are 70 inches. And so this distance is really what we're talking about here. So we just subtract, right? So 120 minus 70, we're going to get 50 inches. And so we're just going to leave that in inches for right now, 50, and then we'll go from there. And so if we're trying to find the distance, the first kid is this little guy right here. We have opposite and adjacent with 43 degrees. So you would say the tangent of 43 degrees equals opposite over adjacent. And if we want to find the distance for this guy right here, then it's the tangent of 29 degrees equals opposite over adjacent. And you would subtract those two, basically, to find it, right? And so if I solve this, I would say, well, this is going to be 50 divided by 40, tangent of 43, right? That's what x is going to be. And y is going to be 50 divided by the tangent of 29 degrees. And I really want to find the distance between x and y, right? The distance between x and y. I want to find the difference, rather, what's left over. So I would take y minus x. right, to find just that. And so that's what I would actually do. I would say, well, this minus that would give me what I'm looking for. And so you do that, you get 36.6 inches. And of course, when you convert that, it's like 3.04 feet. So that's why it's approximately 3 feet.